morning, everybody. Here with you today from Marion, South Carolina, looking at a fumigation trial in peanuts. One of the primary things that we're evaluating here is uniformity of emergence. If you get uniformity of emergence and you get better emergence, you have more yield-bearing plants per acre. Another thing we're looking at is uniformity of growth. Peanuts are mechanically harvested all at one time. So when every plant is in the same growth stage, everything is maturing the same, just through harvest efficiency, you get a better yield. Peanuts are also very sensitive to maturity. All peanuts on the vine do not mature at the same rate. We'll show you more about that in a future video where we're doing some pod blasting to evaluate just how mature they are, looking at differences in treated versus not. Another factor of what we're doing here is looking at control or suppression of soil-borne pathogens, primarily southern stem rot. I'll show you in just a second what a good example of that looks like. But all of these factors impact peanut yield. And we're looking at how chloropicrin impacts all of those factors in this crop. So back in this Marion, South Carolina peanut field, I want to show you examples of a healthy canopy in a peanut plant. You can see all the stems are still green. These circular lesions that you see on leaves are leaf spot. That's a foliar disease that comes into the plant primarily late season and will eventually defoliate the plant to where it can't carry out photosynthesis, which may also be yield limiting, but it's not too bad in this case. But primarily what we're looking for is healthy down at the base of the plant. All the stems are still green, nothing's hollow, everything's holding well, you don't see any dieback, versus a plant that has southern stem rot. You can see here, this is brittle, broken. You can see down in the base of the plant right here, you can kind of see that mold developing at the base of the plant. Chloropicrin has suppression activity on this fungi, and so we're seeing how that's going to impact yield across this entire farm. As a continuation of our fumigate trial in peanuts, this is another difference that we're seeing between treated and non-treated. So on the right is a chloropicrin treated peanut. On the left is a non-chloropicrin treated peanut or grower standard peanut. All of these little balls that you see on the root system are nitrogen fixation nodules, which is something that's done by legumes where they fix their own nitrogen and pull an unusable form out of the atmosphere and convert it over to a usable form. And this is specific to legumes, and peanuts are quite good at this. And we know that chloropicrin shifts the bacterial community in soils. And the rhizobium bacteria is widely responsible for this nitrogen fixation. So possible that chloropicrin's having a positive impact. As you see, both of these root systems are healthy. There's no pathogen impacting these. There's no nematode galling. But we do see a difference in root size, just overall root volume, and also just the nodule difference in terms of size and quantity. This represents about 20 peanut plants in a field that were pulled, 5 plants in 4 different reps randomly across the fumigated treatment. And we shucked all of those off, and then we pulled a subsample of those, blasted the outer shells off to where we can see maturity. And you can kind of see here on this curve, the red curve is optimum maturity in 20 to 24 days. Yellow curve is 10 to 14 days, and the green curve is optimum maturity now. So anywhere where you see a gap, like you see it here, means you want to shift that over to get into the optimum range. So what we see here is it's probably 7 to 10 days max. You don't want to lose this portion to shift this portion over, because all of this can be in a marketable range. So the more level the curve is, sorry, it's a tractor coming by, the more level the curve is, generally the more you can get when you go and harvest. If it was real steep and dropped off, you're going to risk losing these to gain these. So this is an ideal situation. What we're seeing fumigated versus non-fumigated is fumigated is about 5 days in front, maturity, same variety, same field, of non-fumigated. We would think that's a representative of just more green days, getting out of the ground faster, developing a better root system earlier, having less disease pressures, and the plant just being able to mature quicker.